So this this equation, let's just make sure we understand what it's saying. It's saying that a squared plus b squared is equal to c squared. Now, we've got these different simulations, and we've got a video here. I'm going to just I think what I'm going to do is I'm going to make some squares, and I'm going to make a triangle out of these squares. I'll show you what I mean. I'm just going to pause this video for a moment and I'll get that ready. So, so basically, what we're saying is that, well, if you say this triangle here is the same as that triangle up there. You can see it slightly differently, but we've still got the right angle down at the bottom left. If I make these arrows here, then the length of that side, which would be B, that's very tiny. That's a bit better. So that means the length of this triangle is B, but also the length of that side is B. And because this is a square, then basically the height of that square would also be B, right? So the area of this square would be B squared. So similarly, if we do this one here, and that one's going to be A. Again, the width is going to be A as well, so the area of that one will be A squared. And this one, the area is going to be C squared, isn't it? But we'll just label it as well. So that's C. So it's going to be C by C. So the area of this will be C squared. So if it's true that A squared plus C squared is equal to, A squared plus B squared is equal to C squared, then that would mean that the area of this plus the area of that is equal to the area of this. So, if I just, what I'll do then is I'm going to share my screen, and we'll have a look at some of these simulations which demonstrate that the area of this plus the area of that is equal to the area of that. So here we have this is a right angle triangle. It's very similar to the one I just did a moment ago. This square is full of water, and this square is full of water, and we're saying that the total area of this square plus the area of that square should be equal to the area of that square. So when we rotate it, that's what she's going to do in a moment, we should see that the water drains out of the other two squares and should fill up this big square perfectly because the areas are the same. Now, whoever's watching this video, might think, well, hang on a second, this isn't area, this is volume. But do we get around that by saying that essentially you have to trust me that the depth of all of these squares is the same? So the dimension that goes into the screen, the depth of it is the same. The thickness of the block is the same in each case. So we're only interested in the area, and so if we do the area times the depth, that gives you the volume anyway. So I could go into that in a bit more detail, but I'm not going to for the moment. I'd like to get this simulation up as well, but looks like I didn't give a link, so I will do that now. Okay, so you've got the link there now. It's up here, but let's just open it up then. So basically, as I said again, the area of these two squares should be equal to the sum of the area of these two squares should be equal to the area of the bottom square. And this is a way of seeing it more sort of diagrammatically, so you can see it more convincingly. So if I drag this down, what we're going to do is we're going to take some of these shapes and put them into the bottom square, like that. Take that one and put that one there. That one fits in there, and that one fits in there. So that's quite cool. They've just chopped it up so as it perfectly makes that. This should fill that bit there. So let's see how they do that. So put that one there. That one goes up there, and that one fits perfectly down there. So again, this is just another way of showing that the area of this is equal to the plus the area of that is equal to the area of that. Now, this isn't usually how it's thought of. We just say the square of the length of that plus the square of the length of that is equal to the square of the length of that. But in reality, what it would mean is that the area of this square plus the area of this square is equal to the area of that square. And then we just want to see if we can actually apply it to questions like this. So I'll stop the video there and we'll carry on trying to work out the dimensions of this and eventually see how close we can get to finding out the length of that side up there.